Okay, now I want to talk about a couple of fallacies involving existential elimination. So consider the following sequence. Something is F, therefore everything is F. Now I think that it is clear that this sequence is not valid. If you're not convinced, then consider the following instance of this argument pattern. Something is a frog, therefore everything is a frog. That clearly does not follow. So we do not want to be able to prove this sequence in our system. Nevertheless, we can quote-unquote prove this sequence in our system if we neglect the provisos for existential elimination. So let me go ahead and attempt to prove this in our system. I begin by writing down my premise. My premise is an existential statement. My rules of thumb for working with existential statements tell me that I should go ahead and assume an arbitrary case. So I assume an arbitrary case of the existential statement that occurs on line 1. On line 2, my arbitrary case involves the arbitrary name A. Now my goal is to derive the universal generalization for any x, fx. Here is a way that I might attempt to go about doing that. Here's something that my rules allow me to do. I can go ahead and apply conditional proof to line 2 twice over to get the conditional if fa, then fa. This is a perfectly legitimate application of conditional proof. Now I note that on line 1 I have an existential statement, and on line 3 I have a conditional that has an arbitrary case of that existential statement as its antecedent, and has fa as its consequent. So here's something that I might be tempted to do. I might be tempted to apply existential elimination to lines 1 and 3 in order to get fa. Now, as you can see, this line is highlighted in red. It is not a correct application of existential elimination, and I'll explain why in a moment. But let me go ahead and finish this proof. My goal was to derive a universal generalization, the universal generalization for any x, fx. I have an arbitrary case of that universal generalization on line 4, namely fa. Furthermore, my provisos for universal introduction are met. I can go ahead and replace a with the variable x and put a universal quantifier out front via universal introduction, because line 4 itself does not depend on any assumptions, so it doesn't depend on any assumptions involving the arbitrary name a. So this is a correct application of universal introduction. Everything that occurs in this proof is correct except for the application of existential elimination that occurs on line 4. And here's why that application of existential elimination is not correct. So the arbitrary name that I used to replace the variable when I assumed my arbitrary case on line 2 was A. So my provisos for using existential elimination tell me that one of the things I need to do is I need to check the conditional that I use when applying existential elimination. In this case, that's the conditional that occurs on line 3. I need to check it, and I need to make sure that the arbitrary name that I'm using to replace the variable for the purposes of existential elimination does not occur in the consequent of that conditional. Well, that arbitrary name is A. The consequent of my conditional is fa. A does occur in the consequent of that conditional, so I am not permitted to apply existential elimination to get line 4, because my proviso, one of my provisos for existential elimination, is not met. Namely, the proviso that says that the arbitrary name that I use to replace the variable cannot occur in the consequent of the conditional that I use for the purposes of existential elimination. So this is not a correct application of existential elimination. So this entire proof is incorrect because it has an incorrect step on line 4. Okay, let's look at another fallacy involving existential elimination. So consider this sequence. Something is F, something is G, therefore something is both F and G. Well, I think that a moment's reflection shows that this is not a valid sequence. Consider the following instance of this argument pattern. Something is a frog, something is a gecko, therefore something is both a frog and a gecko. Well, that clearly does not follow. Nevertheless, once again, we can quote-unquote prove this sequence in our system if we're not sufficiently attentive to the provisos for existential elimination. So let me attempt to prove it. I begin by writing down my premises. I notice that my premises are existential statements. My rules of thumb for working with existential statements tell me that I should go ahead and assume arbitrary cases of those statements. So let me do that on lines 3 and 4. On lines 3 and 4, I assume arbitrary cases of the existential statements that occur on lines 1 and 2. And in both of these cases, I use the arbitrary name A to replace the variable X. Okay, now I want to prove an existential statement. My rules of thumb for proving existential statements tell me that I should try to derive an arbitrary case of that statement. So I'm going to make it my goal to derive FA and GA. That's easily done. All I need to do is apply and introduction to lines 3 and 4 to get that. That then puts me in a position to apply existential introduction to line 5 to get there exists an X such that Fx and Gx. Now, so far everything I've done in this proof is correct, but I'm not finished because even though I have my desired conclusion, I'm dependent on the assumptions that I made for the purposes of existential elimination on lines 3 and 4. So I need to discharge those assumptions. So let me go ahead and discharge the assumption that I made on line 3 to get the conditional that occurs on line 7. Of course, I made the assumption that I did on line 3 for the purpose of existential elimination. So to carry on with this proof, to carry on with eliminating at least my dependence on the assumption that I made on line 3, I'm going to want to go ahead and try to carry out a proof by way of existential elimination. So at this point, I might be tempted to apply existential elimination to lines 1 and 7 to get what I have here on line 8. As you can see, however, line 8 is highlighted in red because this is not a correct application of existential elimination. And here's why. So I need to check my provisos for applying existential elimination. So one of my provisos tells me that the consequent of the conditional that I use in applying existential elimination cannot contain the arbitrary name that I used to replace the variable when I assumed my arbitrary case. So the arbitrary name that I used to replace the variable when I assumed my arbitrary case was A. I look at the consequent of this conditional and I see that it does not contain the arbitrary name A. So that proviso is in fact met. So we're fine there. But now I also need to check the lines that I use when I apply existential elimination. I need to check those lines and make sure that those lines do not depend on any assumptions involving the arbitrary name A. Well, one of the lines that I use is the first line, line 1. It's a premise. It depends on no assumptions, so the proviso is met there. But when I look at line 7, I see that line 7 depends on an assumption made on line 4. And when I look at the assumption made on line 4, I see when I look at line 4, I see that line 4 is GA. And that line does contain the arbitrary name A. So line 7 depends on an assumption involving the arbitrary name that I use to replace the variable when I assume my arbitrary case. So one of my provisos for applying existential elimination is not met. So line 8 is incorrect. It is an incorrect application of existential elimination. Okay, but let's pretend that I don't notice that, and I'll carry on with the proof. Okay, so on line 8, I still haven't eliminated all my assumptions. I'm now dependent on an assumption that I made on line 4 for the purpose of existential elimination. I need to discharge that assumption, so I do that by applying conditional proof to lines 4 and 8. That then puts me in a position to apply existential elimination to lines 2 and 9. I'm in that position, that is, provided that my provisos are met. So the arbitrary name that I use to replace the variable is A. So I need to check the consequent of the conditional that occurs on line 9 and make sure that it does not contain the arbitrary name A. It does not. I need to check the lines that I use I need to check the lines that I use for the purposes of existential elimination, namely lines 2 and 9, and make sure that those lines do not depend on any assumptions involving the arbitrary name A. But when I check those lines, I see that neither of them depend on any assumptions at all, so that proviso is met. So the provisos for applying existential elimination are met in this case. So on line 10, I do correctly apply existential elimination, and this gives me my desired conclusion. So this entire proof is correct except for the step that occurs on line 8. But once again, a proof is only as good as its weakest link, and because the step that occurs on line 8 is incorrect, the entire proof is incorrect. And that, once again, is a good thing because we noted that the sequent that we see here is not valid, so we do not want to be able to prove it in our system. So what I've shown you now is the dangers of not appropriately attending to the provisos for universal introduction and existential elimination. If you don't attend to those provisos, you can quote-unquote prove invalid sequence.